Hi, in this video we're going to talk about the material conditional and its symbol, which is the right arrow, and its semantics, that is, what it means. Let's take a look at it. Alright, so the material conditional symbol is this arrow. That's the symbol that our textbook uses for it. And it reads as if then. So if we look down here, the way that this proposition would read is if A is a cube, then B is a dodecahedron. Alright, so roughly speaking, the material conditional corresponds to the following English locutions. If P, then Q, or sometimes in English we leave off the then. If P, Q, and this next one oftentimes trips up students. P only if Q. This roughly corresponds to the then. So P only if Q means the same thing as if P then Q. That's what trips up students a lot. In English, sometimes we flip around where the if statement is and where the then statement is. So Q, comma, if P. Or sometimes we use different locutions than the if then locution. So Q provided P, for instance. Alright, so the way that our symbol works in terms of connecting other statements in order to form a more complex statement is it always situates itself in between the statements that it is connecting. So here we're connecting these two statements. But we can also connect complex statements. So if we look at this example, this sentence that's being connected by this arrow is atomic. However, it is also on the right side connecting that complex sentence that is a disjunction. So the way that would read is if A is a cube, then either B is a dodecahedron or B is large. And we got a typo here. I'll erase that. All right, and so that's a little different than the way that the if-then locution connects the sentences in English. So while the then is in between the sentences like the arrow is, we have this if that's hanging out in front. So it's a little different than that. All right, so here we're taking a look at some of the jargon that is associated with material conditionals. A material conditional will have an antecedent and it will have a consequent. The antecedent, if we are dealing with the if-then locution, is what comes after the if. So in this case, it would be the Chiefs win the Super Bowl. If we're dealing with the only if locution, it is the statement that comes before the only if. Again, that's going to be the Chiefs won the Super Bowl. The consequent, if we're dealing with the if-then locution, is what follows the then. So that will be, they will be world champions in this case. And when dealing with the only if locution, it again is what follows. So again, it's going to be, they became world champions. All right, so every material conditional expresses what's called a sufficient condition, and every material conditional expresses what's called a necessary condition. So what is a sufficient condition? What is a necessary condition? So something X is a sufficient condition for something Y, just in case Y always obtains when X obtains. That is, the instantiation of X guarantees the instantiation of y. So another way to think about that is x suffices for y. So think about being a snake as an example. So being a snake, x suffices for being a reptile. I might not know anything else about you, but if I were to know you were a snake, then that guarantees that you're a reptile. So I'll also know that you're a reptile. Okay? So it guarantees, it suffices, it when x is true, y will never be false. All right, so x is a necessary condition for y, just in case y never obtains without x obtaining. So it's necessary in the sense of a requirement. All right, so the instantiation of y requires the instantiation of x. You cannot get y without having also x. Another way to think about it is x is needed for y. So again, we can use the same sort of example. Being a reptile is required for being a snake. You can't be a snake unless you're a reptile. So you have to meet that requirement of being a reptile before you can be a snake. Now, just because you are a reptile, that doesn't guarantee that you're a snake. Maybe you're a lizard, but you can't be a snake if you're not a reptile. That's why being a reptile is a requirement for being a snake. The antecedent of a conditional always expresses a sufficient condition for the consequent of the conditional. So if you think about it, when I say if P then Q, I'm telling you P is going to get you Q. P is going to guarantee Q. P suffices for Q. That's what I'm asserting to be the case. So if we have, going back to the snake reptile example, if S then P, then R rather, what I'm asserting is that being a snake is going to get you that you're also a reptile. Right? It's going to suffice for being a reptile. There's other ways to be a reptile than being a snake, but being a snake is one of those ways that's going to get you to be a reptile. The consequent, on the other hand, the consequent of a material conditional expresses a necessary condition for the antecedent to obtain. So if you think about it, going back to if P then Q, when I say if P then Q, because P guarantees Q, that's what I'm asserting, that P guarantees Q, then if I don't have Q, there's no way for me to have gotten P, because otherwise I would have Q, but I don't. I have not Q. So that means Q is a requirement for being P. Going back to the snake and reptile example, our consequent is representing a necessary condition for the antecedent, because if it's true that being a snake guarantees that you're a reptile, if it suffices for being a reptile, but then I find out that you're not a reptile, there's no way for you to be a snake. So being a reptile is required. It's a necessary condition for being a snake, because snakeness guarantees reptileness. So if you don't have reptileness, you don't have snakeness. All right, so let's talk about the semantics of the material conditional. That is, what does the material conditional mean? There's a couple of ways to think about it. One of the ways to think about it is to think about the cases in which material conditionals turn out to be true. A material conditional if P then Q is true if and only if one of these three cases obtains. P is false, that is, the antecedent turns out to be false. Q is true, that is, the consequent ends up being true. Or both P is true and Q is true. So if one of those three cases obtains, then the material conditional gets the value true. The other way to think about this, and one that I think is easier because you only have to keep track of one case, is to think of the one situation in which a material conditional is false. And a material conditional is false, so a material conditional if P then Q is false, if and only if both the P is true, that is, the antecedent is true, and the Q is false, that is, the consequent is false. So when you have a material conditional in which the antecedent is true and the consequent is false, then the material conditional is false. Well, why is that? Remember that a material conditional, the antecedent is saying that when that obtains, when the antecedent obtains, the consequent is going to obtain. So if P, then you're going to get Q. Well, the case in which you get P, that is, the antecedent is true, and you didn't get Q, that is, the consequent is false, that's precisely the case in which P did not get you Q, when the antecedent did not get you the consequent. And we can see the very same thing represented in this truth table. We have 4 situations. We've got situation 1, 2, 3, and 4. Our first situation is a case in which the antecedent and the consequent are both true, and that outputs true. That's just this case. Case 3 is a case in which the antecedent is false, but the consequent is true, corresponding to actually both of these cases. And that spits out true. Case 4 is a case in which the antecedent is false. So that corresponds to case 1, and that returns the value true. And there's only one case that gets us false, and that's when the antecedent is true, but the consequent is false. When getting P being true, when getting P didn't get you Q, but that's what if P then Q asserts to take place. That's what is being asserted to be true. So it's false when you got the antecedent, but you didn't get the consequent. It's false when the antecedent is true and the consequent is false. Alright, so the Hintica game also provides us a way of understanding the semantics of a material conditional. And it tells us that if you have committed yourself to the truth of a material conditional if P then Q, then you have committed yourself either to P being false or Q being true, or that P is true and Q is true. And you can notice that that is just lining up with those 3 situations. The first situation, the third situation, and the fourth situation on the truth table. Alright, let's try playing the Hintica game with a couple of material conditionals to see how it works out. Alright, so let's say we have the following sentence: if A is a cube, then A is small. And we have a world in which we have A,
and it is indeed small, but it is not a cube. Now you might be tempted when we play this game, since the antecedent is false, to maintain that the entire material conditional is false. So let's try saying that it's false. Yes, I believe that if A is a cube, then A is small is false. And notice it tells us that if A is a cube, then A is small can be rewritten as either it's not the case that A is a cube or A is small. Turns out those are logically equivalent, because in any of the three cases that make it true, it'll either turn out that A is false, or that is, the antecedent is false, or the consequent is true. Okay, so I believe that that sentence is false. I'm going to continue and say, yes, I do think that that sentence is false. So it's going to tell me that, or ask me, so I believe both of those formulae are false. And I'm still going to continue, even though I can tell that A is not a cube is true, since A is a tetrahedron. So I believe that's false. I'm going to continue and say, okay. So I believe that A is a cube is true. Yep. Oh, but I lose. I lose because the fact that A is a tetrahedron makes the antecedent of the consequent, of the conditional false. Okay. Let's take a look at what it looks like when we say that that sentence is true. Yep. I think that if A is a cube, then A is small is true. We've already seen that it can be rewritten as it's not the case that A is a cube or A is small. So I believe that at least one of those formulae is true. And now I have to pick which one. Well, it's true that A is small. Hell, it's even true that A is not a cube. So I win by picking that A is small, but I could also win if I pick that A is not a cube. But in any case, I've won. So we can see that what it's doing by providing a logically equivalent sentence here, it's resolving down the commitments of saying that if A is a cube, then A is small is true. Namely, I must either believe that the antecedent is false or that the consequent is true. All right, so let's say that A is a tetrahedron. If A is a tetrahedron, then it's medium. Now our antecedent is true because A is in fact a tetrahedron, but A is small, it's not medium. So let's say for some reason we thought this was true. Again, it can be rewritten as either the antecedent is false, that is, it's not the case that A is a tetrahedron, or A is medium. So I must think that at least one of these is true if I'm committed to this disjunction. Okay, maybe I can see that it's definitely a tetrahedron, so I don't want to pick this one. But maybe I got confused and think that it's medium. Nope, I've lost. So it turns out that since I committed myself to it being true and I lost, that the material conditional, if A is a tetrahedron, then A is medium, is actually a false proposition. Again, we see that by providing us a logically equivalent sentence and then resolving it down to our commitments, it allows us to better appreciate um, the meaning of a material conditional, when it's true and when it's false.
All right, that finishes this video on the material conditional symbol and its semantics. I hope you found it helpful.